Hello, this is Miss Jackson. I want to make a quick video covering the Unit 1 test review that's coming home with your child this week. We'll start with problem 1. The first thing I want to point out is that I realized when I was looking over this, there was not a correct answer choice. So I had to alter mine, and you'll see that on the screen where I scribbled one out, a number out, and changed it. On the copy that's going to come home with you, I will go in and edit that so that it's not scribbled, and there will be a correct answer choice. Number 1 says, Tiffany wrote a number on her homework paper. The number she wrote was 927,436. If the digit 2 is replaced with a 0, which statement best describes the change in the value of the number? Well, if we change this 2 to a 0, we know the number got smaller. It decreased. We just need to know how much did it decrease by. To figure that out, we have to think about what place value column are we working in, and how much did the number change, or how much did that column change? Well, our number had 2 10,000s in it, and now it has no 10,000s. So our number has decreased by 2 10,000s. The answer choice that matches that is going to be C. The number would decrease by 20,000 because 2 10,000s equals 20,000. At the bottom of this, and at the bottom of several of these problems, I've added little extensions, questions you can ask to go further with this problem. I can't tell you on the test how a number is going to be altered. They may increase a number by changing a column or a number in it, or they may decrease a number. So you could ask your child, what if we change the 6 to an 8, or the 4 to a 3, the 9 to a 2? And different things like that, just to make sure they understand how numbers are being changed, and how does that change the value of the number? Does it increase it? Does it decrease it? And how much by? They'll need to pay close attention to which digits being changed, and is it in the ones place, the tens, hundreds, thousands, 10,000s, or 100,000s? Because if we change, for example here, the 2 to a 0, it wouldn't be correct to say, well, it's changed by a value of 2, because we went from 2 to 0. That would only be if that was happening in the ones place. It changed by a total value of 20,000 because it's happening in the 10,000s place. Okay, question 2. I put this on here because sometimes the kids see these problems and they just look at all of it at one time and become overwhelmed and almost just give up and just put things there. We've been working in class, though, at looking at number 2 kind of section by section. And if we do that, then we typically don't have much of a problem answering this correctly. Number 2 says, write greater than, less than, or equal to, using these symbols, in each box to represent the comparison of the numbers. So like I said, I like to just take 2 numbers at a time. The first number is 38,749. The second one's 37,948. Well, we know 38,000 is greater than 37,000, no matter what the last few numbers are. So we'll put the greater than sign. Kids have learned that this is an alligator that likes to eat the bigger number, and that is my very best alligator drawing, and that is why I'm not your art teacher. There you go. It likes to eat the bigger number. Now that we have finished this first little section, we're going to compare the next 2 numbers, 37,000, and this one starts with 37,000, which means we're going to have to go look at the hundreds place, because the 10,000s and the thousands place are the same. That doesn't help us any. Looking at the hundreds place, one has a 9, one has a 4. 9 is greater than 4. Therefore, we're going to use this greater than symbol. 37,948 is greater than 37,489. We just need to compare our last 2 numbers. We have, I wish I put that line somewhere better. Let's change that. 37,489 and 34,978. Well, again, 37,000 is greater than 34,000. We don't have to look at the hundreds or the tens or the ones. The thousands places as far as we have to go. And it's going to go that way. And then we're going to double check our answer. I feel like I have done this correctly, and that's a win. Perfect. Okay, let's move down to problem 3. Now, problem 3, we're just going to start learning this on Monday. We'll work on it on Tuesday and even Wednesday a little bit if we need to. So if you start looking at this Monday with your child and they're not totally sure what this is, it could be that it's new and we're working on it. It says, which number line best represents point P as the number 2,376? Now, the first thing I'm going to look at are these numbers down here and see what they are. It looks like they're counting or increasing by 100 as they go along. I know the number 2,376 is going to fall somewhere between 2,300 and 2,400. So if I look at answer choice A, that's not going to be the right place because that is going to be too small. That's probably going to be somewhere around the number 2,276, which is not what we need. Looking at B, that looks good. It's closer to the 2,400 than 2,300. These are like little prompts you can give your child. Do you think this number is going to be closer to this number or that number? And why? So I'll put a little star by B. That looks promising. Looking at C, well, the dot is smack dab on 2,300, which means that can't be it. And D, the dot is right on 2,400. That can't be it. So the best choice for us is going to be B. That one shows reasonably where 2,376 would be. Some extensions you can add to this are just asking your kid, where would this number or that number or another number be located on one of these number lines? And if you want to get into rounding, which is really what we're trying to get to with this, you could ask them, what would 2,376 round to if rounding to the nearest hundred? Well, you can look. It's way closer to 2,400, so that is what it would round to. All right, looking at number 4, it says the expanded form of a number is shown. What is the standard form of the number? I like to use a place value chart for this, and I encourage kids to use it all the time. Some do, some don't. In the end, I can't make them do it. But a place value chart is very helpful because it helps us organize this information. And sometimes I will draw it just like this and label it ones, tens, hundreds, thousands, 10,000s, and 100,000s. Looking at the number, it says I have 90,000. I know that is 9 10,000s. I have 1,000. I have 700s, and I have 5 ones. The most common mistake, and we've worked and worked and worked on it in class, that happens is kids will take this number and write that down, and that's not the correct answer. We have to put a 0 in the tens place to hold that spot. Once we've done that, we can find our answer right there, 91,705. Please encourage your child to use a place value chart, especially if they're struggling with this, because it just helps us not to make so many little mistakes that we know better than to make. I like the extension on this one. It says debate. Does 50,000 plus 40,000 plus 1,000 plus 400 plus 30 plus 5 also represent the standard form of the answer chosen? So what we would need to do is go start combining the numbers that come or represent the same place values. So 50,000 and 40,000, those are both numbers in the 10,000s. Well, 50 and 40, that's going to be 90,000 plus 1,000 plus, we'd have to combine this 400 and 300 for 700 plus 5. Yes, it does represent the same thing. It is the same number. It's just been decomposed even more than what was up top. All right, let's look at problem 5. This one is also one that should be a fairly simple one to get correct. The kids have worked with base 10 blocks for a very, very long time, many years, but it's one where sometimes we look at it and get overwhelmed. And so I try to have them just go section by section. It says, which of these models represent the same number? Well, to figure that out, I need to figure out what is each model representing. This square is a hundreds flat. It has a value of 100 because it's made up of 100 ones cubes. Well, I see 1, 2, 3 of those. So I have 300. I have 3 10 rods. So that's going to give me 30. And then I have 3 ones cubes. So I have a 3 in the ones place. Model A represents the number 333. Model B, I see there are 1, 2, 3 10s rods. I'm going to put 30 right there. So that's what that represents. And I see a whole lot of little ones. Let's see. Yep, there are 10 in this row. There are going to be 10 in that row and 10 in that row. Well, that's another 30 because 10 plus 10 plus 10 is 30. And then we have 3 ones right here. Well, 30 plus 30 is 60 plus 3 is 63. And I'll write that there. Well, I know A and B don't represent the same number. Let's check C. I made up a model C diagram for us here. I can see right here that there are 10 10 rods. And I know that 10 10 rods has a value of 100. That's what makes up a 100 flat. So if I turn these into a 100, I can see that I have 3 of those. That's going to represent 300. I have 3 10s rods, that's 30, and then 3 of these ones here. That's 333 is what that represents. I'm going to write that down here. And looking at that, I can see that Model A and Model C are the ones that represent the same number. So now I'm going to go find that answer in the bottom. A says Model A and Model C, because 3 10s is equivalent to 300s. 30 10s is equivalent to 300s. That sounds good. B, Model A and Model B. Well, I know that can't be right because it's not Model A and Model B. C says Model B and Model C. Well, that is also not correct. And D, none of the above. Well, that's not true because A and C represent the same number. So my answer there is going to be A. Moving down to 6, we are almost finished with this. It says the names and heights above sea level of 4 mountain peaks in Guadalupe Mountain National Park are listed in the table. Here's the table. Which mountain's height makes the comparison statement true? Here's the comparison statement. It says 8,510 is greater than which mountain peak? Well, I'm just going to go number by number and see, is 8,510 greater than that or not? So let's start with Bush Mountain. Is 8,510 greater than 8,564? No, it is not. Hey, let's use a pen on that. That would work better. Is 8,510 greater than 8,508? Yes, it is. By 2 little numbers, I believe. 2 ones. Is 8,510 greater than 8,615? Nope. And is it greater than 8,749? Also no. That means that 8,510 is greater than Bartlett Peak. So I'm going to find that answer choice, circle it, and that's it. The extension on this is to list the mountain peaks in order from least to greatest, and then to do it in order from greatest to least. A vast majority of the kids know what the terms least and greatest mean, but there are still a few that struggle, so it is not a bad idea to have them list that to make sure that they're understanding that least means the smallest and greatest means the biggest. Okay, last couple of problems. Number 7 says the number 93,154 is represented and described several ways below. It's described as 93,154 in word form, as 90,000 plus 3,000 plus 100 plus 50 plus 4, that's expanded form. It's then represented again in expanded notation, 9 times 10,000, 3 times 1,000, 1 times 100, 5 times 10, and 4 times 1. And lastly, and this is probably the most important part of this, It's described as words, or using words as the sum of 9 10,000s, 3,000s, 100, 5 tens, and 4 ones. This is overwhelmingly the number one thing we missed on an assignment that we did last week. It's kind of a cumulative assignment of all the things we've learned so far. And so I'm going to go back this week and we're going to practice this some more, but you may want to practice it at home too. When it gives us, I just call these like the clue questions. To me, it's almost like a little mystery that you're supposed to solve, what number is being described. I always start out with a place value chart. Got a label, ones, tens, hundreds, thousands, 10,000s, oh, that ran off the page, and 100,000s. And then I'll just go section by section of what's being described and I plug it into the chart. 9 10,000s. Well, I know this is my 10,000s here, and there are 9 of them. 3,000s. I'm going to go to the thousands place and plug in a 3. 100. I'll put a 1 there. 5 tens and 4 ones. Once I've done that, then the number becomes very, very clear as to what this is. 93,154. You may want to think up a whole lot of numbers and describe them to your child and have them practice putting them on a place value chart and writing them in standard form, which is what this is right here when we use numbers to represent a number. We actually write it with numerals. And you might want to make sure you go to the 100,000 sometimes, maybe leave out a place. So maybe describe a number that has no hundreds or no tens or no 10,000s or something like that, just to make sure that they can accurately plug that into a place value chart and determine what that number is. On this part right here, oh no, that's the wrong thing. That's okay, we can fix it. I gave a number and asked them to describe and represent them in the same ways. Word form, expanded notation, and then describing it with words. Okay, the last thing we have is, last two things we have. One is a picture of place value discs. Just like with other things we've talked about, just pretty simply make a place value chart. And plug in what it's telling us. So right here I see that we have 1, 2, 300,000s, so I'll put a 3 there. 1, 2, 3, 4 10,000s, so I'll put a 4 there. 1,000, so I'll put a 1 there. 1, 2, 3, 4, 5 tens. I'm going to be very careful and make sure I put that in the tens place. Then I have 1, 2 ones. I'll put a 2 in the ones place. I have to go back and put a 0 in the hundreds place to make sure I don't change the value of this number. And the last thing we have is number 9. These are kind of like a mystery problem as well. It says Miss Jackson is thinking of a number. Use the clues below to determine which number Miss Jackson is thinking of. The clues are: the number is greater than 61,302. The number is less than 63,889. The digit in the tens place is even. So one way that kids can solve this, and we'll work on this moving forward, is to use a number line. Well, I know that the smallest this number can possibly be is 61,300, really 3, but I'll just put 302 here. The largest that this number can be is 63,889 because it says it is less than that. So I know that the answer is going to fall somewhere in between these two values. And then lastly, the digit in the tens place is even. I might start with that to eliminate some options. I'm going to look at the tens place on each one of these numbers. If it is not an even number, I'm going to cross that out. Well, this one has a 0, that's even. This one has a 1, that is not even. That can't be the answer. This is a 2, it's even. This one has a 3, not an even number. Let me get rid of that. That brings me down to 2 answer choices. And I'm going to decide where would these go on this number line. Well, the first number I'm looking at is 64,006. I know that 64,000 is greater than 63,000, which means this answer is going to be somewhere over here. That doesn't fall within my clues because it says it has to be less than 63,889. I'm going to plug in, though, this last answer choice just to be sure. 62,222. I'm going to say this would be about 62,000 there. So 62,222 would probably go somewhere in that area. Okay, that means C is the answer choice. It is the only one that falls within the clue of greater than 61,302, but less than 63,889, and is even in the tens place. Now, I just put a little extension. How many unique numbers can you think of that would fit in this clue, fit in this space here, that has an even digit in the tens place? There's probably going to be a whole lot of those. It's okay if your child only generates a handful, as long as you can tell that they kind of know what they're doing there and know what this clue means. Feel free to come up with your own clue problems and give those to your child also. That would be beneficial. Okay, I think that is the end of the review. If you have any questions, please reach out and ask, and I'll be happy to answer them the best I can. Again, when it comes to the problems on the number line, we're working on that Monday, Tuesday, and possibly some of Wednesday. And we're going to use it as a tool to round numbers because it gives a very good visual of what is happening, and it helps kids visualize more when we're rounding. Like, why are we rounding to this number? Well, if you look at it on a number line, it's closer to that, and they can visualize that. But that takes some time to develop also. So we'll work on that all year. If you have any questions, please let me know.